Find the equation of a quadratic function in standard form that has zeros at -2 and 1 and passes through the point 2, 8. A quadratic function is a parabola, and there's three popular formulas for them. There's vertex form, intercept form, and standard form. We aren't given the vertex, so we're not going to use vertex form, but we are given the zeros, which ultimately means the x-intercepts, so we want to use intercept form. And this third one is called standard form, and that's what we need to have our answer written in. So this -2 is essentially -2, 0. This 1 is ultimately the point 1, 0, and then we can just bring down this point 2, 8. So the -2 is our p, and the 1 is our q. And then in order to solve for a, we can treat 2 as x and 8 as y. We'll plug in 8 for the y, leave a alone, plug in 2 for both x's, plug in 2 for the p, and 1 for the q. 2 times 2 is 4, and 2 minus 1 is 1. Bring down everything else. 8 times 4 times 1 is 4a, so we have 4a equals 8. Divide both sides by 4, and we get a equals 2. So now we can rewrite this as y equals, we can plug in 2 for the a, then we have x minus p, which in this case would be x plus 2, and we have x minus q, which would be x minus 1. Then we can FOIL this out. We end up with x squared plus 2x minus 2. Combine like terms, we get y equals 2x squared plus x minus 2, and then distribute the 2. We have y equals 2x squared plus 2x minus 4. And that is our answer in standard form. And here's the graph of it right here, and you can see it passes through -2 and 1, and it also goes through the point 2, 8. How exciting. If you guys want to try more of these problems, there's a link in the description with more problems like this.